In this video, I want to show you guys how to find the equation of the tangent line with derivatives. So say you have the equation y is equal to x cubed, and you want to find the equation of the tangent line at x equals 2. There's three things you're going to need. You're going to need x, you're going to need y, and you're going to need the slope. So we already have x. It's equal to 2. In order to find y, all we have to do is plug in 2 into our equation. So we take 2 and we plug it in for x, and 2 cubed is equal to 8. So now we have our y. It was that simple. Y is equal to 8. To find our slope, we need to take the first derivative of our function and then plug in x into that derivative. So using the power rule, to find the derivative of x cubed, we will take the exponent and bring it out to the front and then subtract 1 from the exponent. So this is our derivative is going to be equal to 3x squared. Okay, that's our derivative. Now all we need to do to find the slope is plug in x into our derivative. So if we plug in 2 for 3x squared, we will get 3 times 2 squared. So 2 squared is 4, and then 4 times 3 is equal to 12. So 12 is equal to m. So now all we need to do is we need to plug all these numbers. We have all the numbers we need. We need to plug them into the point slope formula. And the point slope formula is y minus y1 is equal to m times x minus x1. So x is equal to 2. Well, we can write it like this as our coordinates. So this will be x1 and this will be y1. So we just leave y as is, minus y1 is equal to 8 is equal to m is 12 times x, we just leave it as x, minus x1, and x1 is equal to 2. So this is completely fine to leave your answer as like this, as in the point slope form, but if you want it in the form of y is equal to mx plus b, you're going to have to simplify, and to simplify we are going to distribute our 12. So this is going to be y minus 8 is equal to 12 times x is 12x times 12 times negative 2 is negative 24. We're going to add 8 to both sides. And this is going to leave us with y is equal to 12x minus 16. And that is the answer to this problem in the form of y is equal to mx plus b. So for our next problem, say we had y is equal to 3x to the 4th minus 5x cubed plus 6x plus 8. And we wanted to find the equation of the tangent line at x is equal to 1. So we have x, we're going to need y, and we're going to need m. So we have x, and in order to find y, all we're going to have to do is plug in x into our equation. So if we plugged in 1 for all our x's, so this would be 3 times 1 to the 4th minus 5 times 1 cubed plus 6 times 1 plus 8. If we simplified this, 1 to the 4th power is just 1, and 3 times 1 is 3, minus 1 to the 3rd power is 1 times 5 is 5, plus 6 times 1 is 6, plus 8. And 3 minus 5 is negative 2, plus 6 is 4, plus 8 is equal to 12. So our y, this is equal to 12, and that is our y, 12. Okay, so now we need to find the slope. And to do that, we're going to have to take the derivative of our function, and from there, then plug in our x to find our slope. So we have to use the power rule for the majority of these, actually for all of them. So we're going to take our constant, or our exponent 4, and multiply it by 3, and then subtract 1 from our exponent. So that is going to be 12x cubed minus 3 times 5 is 15, and then we subtract 1, so our exponent will be x squared. So this is going to be 15x squared plus the derivative of 6x is just 6, and then the derivative of 8 is just 0, so we don't need to write it. Now that we have our derivative, we can plug in x to find our slope. So 12 times 1 cubed minus 15 times 1 squared plus 6. If we simplify this, 1 cubed is just 1, so 12 times 1 is 12, minus 1 squared is 1, times 15 is 15, plus 6. So 12 minus 15 is negative 3, plus 6 is positive 3. So this is equal to 3, and 3 is equal to our m, which is our slope. So now that we have all the numbers that we need, our x, our y, and our slope, and we can write x, y as 1, comma 12, and this will be our x1, and this will be our y1. So we need to write this, and the way we're gonna find the equation of our tangent line is we're gonna plug all these numbers into our point slope formula, and that is y minus y1 is equal to m times x minus x1. So we just bring down our y, we don't have to change that, minus y1 is 12 is equal to our slope, which is 3, times x minus x1 is just 1. So this is also fine just to keep it like this. This is our point slope form, but if we want it in terms of y is equal to mx plus b, we're going to have to simplify, and we're going to start out by distributing our 3. So this is going to be y minus 12 is equal to 3 times x is 3x minus 3 times 1 is 3. We can add 12 to both sides, and that is going to leave us with y is equal to 3x, and negative 3 plus 12 is positive 9, so 3x plus 9. And this is our answer in the form of y is equal to mx plus b. So for problem number 3, say we have y is equal to x divided by x minus 1, and we want to find the equation of the tangent line at x is equal to 2. So just like all the other times, we're going to need 3 different things: our x, which we have, our y, and our slope. We're going to find our y by plugging in our x for all x's of our equation. So we're going to plug in x here, so 2 divided by 2 minus 1. And this is going to simplify to 2 divided by 1. So our y is 2. To find our slope, we're going to need to take the derivative of this function using the quotient rule, and then once we have the derivative, we can plug in x into our derivative. So if you don't know exactly what the quotient rule is, you should know it if you're at this point in calculus, but it is the bottom number multiplied by the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. So we're going to do that. The bottom, so y prime is equal to the bottom, which is x minus 1, times the derivative of the top, so the derivative of x is just 1, minus the top, so x, times the derivative of the bottom. The derivative of x minus 1 is just 1, all divided by the bottom, which is x minus 1 squared. So x minus 1 squared. If we do a little bit of simplification, x minus 1 times 1 is just x minus 1, and then x times 1 is just x, so this is going to be simplified into x minus 1 minus x, all divided by x minus 1 squared. Okay, so from here, we actually can cancel our x's because x minus x is equal to 0, so we can just cancel them, and this can be further simplified into negative 1 all divided by x minus 1 squared. So now that we have our derivative, this is our derivative in simplest form. Unless we wanted to FOIL, but that would just make it not look like this, okay? It would make it a little harder actually. So we're going to plug in x into our derivative, and that is going to be equal to negative 1 divided by 2 minus 1 squared. So 2 minus 1 is 1. Squared is just 1. So this is going to be equal to negative 1 divided by 1, which is equal to negative 1, which is our slope. Negative 1 is our slope. So we'll just write it here. And now we have all the numbers necessary to find the equation of the tangent line at point x is equal to 2. So we'll write down our formula for our point slope form. Y minus y1 is equal to m times x minus x1. So we'll bring down our y. Minus y1 is 2 is equal to m, our slope, minus 1 times x, just bring it down, minus x1 is 2. So this is sufficient. You can keep it in point slope form, but if you want it in the form of y is equal to mx plus b, we're going to have to do some simplifying. So we will keep y minus 2 for now on the left hand side the same, is equal to, if we distribute our negative 1, this will be negative x plus 2. And then we can add 2 to both sides to isolate y. And these will cancel, so this is equal to y is equal to negative x plus 4. And this is the answer to, this is the equation of the tangent line of this function at point x comma, or at point 2 comma 2. So for our fourth problem, we already have our x1 and y1 terms. So that means the only thing we need to find in order to find the tangent line at point pi over 3 comma 4 is to find our slope. And to do that, we have to take the derivative and then plug in x for our derivative. So to do this, we have a inside function surrounded by a larger outer function, which is squared. So what we're going to need to do is use the chain rule, and we're going to have to take the derivative of the outside function and then multiply it by the derivative of the inside function. So to take the derivative of the outside function, we'll use the power rule. So we'll bring down our parentheses. So we'll bring the exponent out front. This will be 2. And then we'll subtract 1 from our exponent, which will just leave us with 1. And then we'll bring down the inside function unchanged. So secant x. Then we have to multiply it by the derivative of the inside function, which is secant x. And the derivative of secant x is secant x tangent x. So we'll multiply all this by secant x tangent x. Okay, so that's our derivative. To find slope, we then have to plug in our x into all our x's here. So this will be, so this is our derivative. We'll just say f prime of x is equal to this, our derivative. So f prime of pi thirds is going to be equal to 2 times secant of pi thirds. And we don't need to write to the power of 1 because it's implied, times secant of pi thirds times tangent of pi thirds. Okay, so what we're going to have to do here is simplify all this. But it's easier to rewrite the secant functions in terms of sine and cosine, and then use the unit circle to find the value of these functions. It's best to have the unit circle memorized, or you can just look at it if you're doing your homework or whatever. But so we're going to rewrite the secant functions in terms of sine and cosine, and secant is just 1 over cosine. So we're going to rewrite all the secant functions as 1 over cosine. So this is going to be 2 times Yeah, 2 times 1 over cosine of pi thirds. Well, that's terrible, but let me try to rewrite the next one better. And then we're going to multiply this by 1 over cosine of pi thirds times the tangent, and we'll just keep tangent the same, tangent of pi thirds. You could rewrite tangent as sine over cosine, but it's just easier to do it like this. So cosine of pi thirds is equal to 1/2. You can look on the unit circle to verify, but cosine of pi over 3 is 1/2. So this is going to be equal to 2 times 1 divided by 1/2 times 1 divided by cosine of pi thirds is 1/2, so 1/2 again, times tangent of pi thirds is actually the square root of 3, so times the square root of 3. And 1 divided by 1/2, if you divide it by a fraction, you have to multiply by the reciprocal, which the reciprocal of 1/2 is 2 over 1. So 1 divided by 1/2 is actually 2, so this is going to be 2 times 2 times, and then 1 divided by 1/2 is 2 again. 2 times root 3 is just 2 root 3. So 2 times 2 is 4, and then we'll multiply it by 2 root 3, and 4 times 2 is 8, so our slope is going to be 8 root 3. 8 root 3. And now that we have all the numbers we need, our x, our y, and our slope, we can plug it into our slope point formula. Y minus y1 is equal to m times x minus x1. So we bring down our y, minus y1 is 4, is equal to m, which is our slope, 8 thirds, times x minus x1 is pi over 3, so minus pi over 3. And this is the answer to our problem in point slope form. If you want to get it in the form of y is equal to mx plus b, you'll have to do some simplification, but point slope form is a completely valid way to represent your function.